Okay, friends, the 10-minute bell, casual introduction. Arthur has homework problems, but first we finish B3 lipids. There's a mistake in the notes that I gave you. It confuses HDL and LDL. I felt like a big fat liar yesterday when I was saying the words that were on the thing. Well, I double checked last night, so I'm using different slides. Hopefully they don't have the same mistake, because I'd like not to suck. So we're going to talk about rancidity. Rancidity is just the action of things spoiling. And in the context of fats, there are two ways that things can spoil. There is hydrolytic rancidity. Hydrolytic rancidity can happen to any fat. It's when you hydrolyze this ester bond and recreate the fatty acids. What's wrong is that short chain fatty acids really smell awful. So butyric acid really does smell like vomit, and so if you were to make some of that in your glorious olive oil, you would be pretty disappointed with yourself, right? You take a whiff of the oil and you're like, this don't smell right. It's the fatty acids. But a further problem is going to be that this is acid catalyzed. And so as we create the fatty acids, we're going to lower the pH of the system, and we're going to make the process of hydrolytic rancidity or hydrolysis like faster and faster, so it's autocatalytic. As the stuff spoils, it spoils faster and faster. Positive feedback. I believe that lipase is in the intestine. I believe your stomach relies just on the concentration of HCl being high to start breaking your fats down, but then lipase can come in and cut them, but you have a wealth of biology information in this room, so anyone can tell me I'm old. There's no difference. It's just an admission that all fats go bad this way. And so, like if you're putting oil in your food, you might like to do it toward the end instead of toward the beginning to prevent the food from hydrolyzing while you're cooking. The picture is strange on this one. I'm not completely in support of it. The picture is of the antioxidants are oxidized, is of the oxidation of ascorbic acid. Ascorbic acid, vitamin C, is often added to foods to prevent them from undergoing the other type of rancidity. So in the presence of a double bond, so in a unsaturated fat, mono or polyunsaturated fat, a second mechanism of rancidity can occur, and that is a free radical reaction. You remember free radical reactions from the beginning of chapter 10, everybody? Woo! Free radical reactions. What's the ingredient? UV light. And so has anyone bought olive oil or avocado oil in the recent past?
Olive oil?
Yeah. What does it look like when you buy it?
Green.
We always use green bottles or steel cans, and that's because we want to prevent the light from being able to get to that double bond and cause this reaction. So we are trying to prevent a free radical mechanism of oxidizing those double bonds. When you oxidize the double bonds, you tend to make ketones, and they also tend to have kind of an icky smell. So sometimes when you open olive oil, you can smell that it's like not fresh anymore. Not at your house because y'all go through it. Peanut oil, corn oil, safflower oil, rapeseed oil. I don't know what you people use. We don't use rapeseed in the U.S. We call it canola. It's the same thing, we just don't like the word rape. Rape seed, not grape, rape. No G. You all taught me last time that fats were very high density sources of energy. You told me that there are about 9 calories in a gram of fat, while there were only 4 in a gram of carbohydrate, and we referred to the fact that these were quite reduced, so there was lots of room to keep oxidizing them. And we wrote down a balanced chemical equation trying to show that you can put about, I don't know how to say this, you can put more oxygens on it. So like we mapped it a little bit to try to make it better. Fats are also insoluble in water, and that leads to kind of interesting properties. If you've ever like cooked with brown sugar, baked, used, touched, owned, what happens to it? before you cook it. So like you're storing brown sugar in your pantry. It gets hard. It's because the water in the air is like absorbing into the sugar and messing with it. So the fact that sugar is water soluble or water friendly means that over time it will like kind of collect some water, and that makes it bigger. Fats, on the other hand, are quite hydrophobic, and so they don't expand in the presence of water. They stay a little bit more compact. So not only is there like a more energy per gram thing, there's also just the fact that fats are by themselves. They aren't very good at mixing into the rest of the food that we eat. And so if you eat that piece of fat, like it's got a lot of food in it. So if you eat that pat of butter, like just stick a fork in it and eat it, that is a whole lot of food. The same amount of sugar would just take up more space. The same the same amount of calories of sugar would take up more space. Fats are also not a very popular source of energy in your body. They're harder to use because you've got to move them around your body. They don't dissolve well in your blood because your bloodstream is essentially an aqueous solution. And so we need to have a mechanism of transport, so it's just a slower burning fuel. I was talking to Mr. Lowry today. He thinks this is really cool. His students' bio honors are not dazzled by it. But phospholipids are kind of the same as triglycerides. The only difference is that one of these bonds that was a esterification bond here instead is that phosphate trying to make a phosphoester. Wanted a word for it. You might talk about phosphodiester bonds. This is just one. It will be. Again, there's just a mistake in your notes when it comes to HDL and LDL, so I was trying these. They're pretty similar. I don't know, trying to make it better. What would you get if you hydrolyzed this? Also, I've never seen them before this morning, so it's more exciting for me. That's right, so you would get the fatty acids, the glycerols, and a phosphate. So a reasonable question would be just draw the products of hydrolysis of a phospholipid. And so the point that I've written on a few homework assignments where I thought you guys were lazy, but I got lazy and stopped writing it, is that I feel like this is very much a drawing section. And the expectation isn't so much that you can say the words, you make a fatty acid and you make a phosphate and you make a glycerol. That's the beginning of the conversation. But the end of the conversation is like throwing this down on your page. And so being confident that you can draw that fatty acid. And I don't think it's a big thing, but I think it's it might take a little bit of practice thing. So we know that the phospholipids come together to make membranes. This is a cute phospholipid bilayer. Isn't that nice? You can see that we've replaced that phosphate group with a polar head group, and we show it interacting with the water while we have those two greasy tails coming together and having some sort of a hydrophobic, or we might call it a London dispersion force kind of interaction. What might be interesting here is I already told you what this interaction is. In chemistry, we would refer to it as a London dispersion force. And we would argue it's pretty strong for all of the reasons that Sophia's bottle is still a solid. Those are big plastic molecules. They're absolutely nonpolar, but they are large enough that the London dispersion forces between them are quite strong. So these nonpolar tails, we draw them as pretty small, but they're really pretty large, and so the interactions between them can be quite good. What is the interaction that's keeping the top of this? It's got to be something, right? So I think that the mark scheme is pretty generous with the answer, but like I've got questions as ever. So you know that this is a phosphate in some state of minuses. It's got stuff attached to it, so it's a little bit hard for me to say. To me, it might be a little bit surprising that the phosphates would line up next to each other, because I think if anything, in an aqueous environment, we might assume that they do have a negative charge. But we know that there's lots of water molecules around to hold them in place. And so it's going to be the ion-dipole interaction, I think, is the best answer between the phosphates and the water. It's going to be the interaction between the hydrophilic phosphate and the water is what my biology squad is going to say, but we just don't use the words hydrophilic and hydrophobic to get marks on chemistry exams. We're going to use words like ion-dipole interaction and London dispersion force. Because those are words Margaret knows. London dispersion forces, non-polar form, ion-dipole. They accepted hydrogen bonding, I believe, as an answer, which seems generous. So I'm not terrified of it. I just thought it was an interesting question that I was reading through, trying to make either your quiz or your mock. You know, you never know. This is a good word, amphiphilic. Phospholipids are amphiphilic. That means they like both things, water and not water. Again, they have that polar head that likes water and that greasy tail that does not like water. Lecithin is an example of a phospholipid. I don't know what I'm supposed to do with that wonderful piece of information. So I went down a hole on the internet and I was reading about how you dispose of household grease. You guys go down rabbit holes on the internet, I know you do. How do you dispose of grease in your house? You make like the fatberg. I don't know if you saw the fatberg one, it was disgusting. The problem is that vegetable oils aren't very good at solidifying, and so normally what we do is we pour them into like a plastic container, and so that plastic container will live, 10 times longer than you do, and that's a bummer. And so they're trying to find some environmentally more friendly ways, and so they're making what they call oleo gel, this product from Japan. So somehow they are binding it up into something that like peels off like a gel, like Jell-O. Very interesting. I really want to know more about it. If I had to write my A, I'd be like, can I make my oil gel? Or an EE, yeah, that'd probably be better. I don't know, I just thought it was really cool. So don't pour it down the sink, it's bad, put it in the trash. I agree with both of you. Your moms taught you what my mom taught me. Okay. Lipids are good for you. They're essential fatty acids that you have to take in. If you don't take them in, you will not be a healthy human. Lipids are important for protecting your organs. If you do not have enough body fat, things are not great. Lipids are sources of steroids, and so like if you're not taking in any cholesterol, you're not making any of those hormones that you teenagers are famous for. I got jokes. But lipids are bad because if you eat them too much, you can become obese, and because in some people more than others, I think we currently think lipids can line the walls of your arteries, and you get a disease known as arteriosclerosis, the hardening of the arteries, and that's bad for you. I did on your quiz try to remove all of the questions that asked Emma specifically about like the goodness or badness of biological things, because I thought that that was like a next step. Kind of the biologist had a big advantage over the chemist's moment, and so I wanted to give everyone a little bit more time to review sort of the what's good, what's bad piece, and no one extra time to review like how do I draw a lipid, because that's the real content. So like I chunked all of the 1 mark, tell me a fun fact questions, but I'm still sharing some fun facts. So please don't worry about those for this. Let's see if we talk, oh good, we're gonna hope this is right. So we talked about how lipids can't move in your bloodstream by themselves. They have to go around on lipoproteins, and there are 2 lipoproteins that we talk about. Of course, we call them low density and high density lipoprotein, or HDL and LDL. Woo! LDL is the bad one in this set of notes. That's the correct answer, everyone. We think about LDL, low density lipoproteins, as the bigger ones, but we call them the dump truck. Is not how you learned it?
Wait, what is that called? The LDL?
Yeah.
No, I'm not really good at
So my understanding of the purpose of LDL is to move lipids from your liver into your bloodstream. The problem is that it works a little bit like you're on the freeway behind a dump truck. And so the lipids that it's carrying tend to fall off. And when they fall off, they stick to the arterial surface, and that is the main cause of arteriosclerosis. HDL, by contrast, typically is used to transport proteins from the blood into the liver where it can be metabolized. And we think of that more like a snowplow. As it's going through the bloodstream, it actually scrapes off some of the fats along its way. So this is considered the good fat, and so when you do a blood panel, I thought they usually gave you a ratio of these two things to try to assess something about your health. Yes? School me.
No, I asked you a question.
Oh, shit.
Sorry. It's like the LDL and HDL. Is that like what people refer to when they mean like good and bad cholesterol?
Yes, this is exactly the number that we refer to when we're talking about good and bad cholesterol. So usually when they run a triglyceride panel, I believe they tell you something about the total fat in your blood, and then they tell you something about the ratio of these two things. And you want to have more of this and less of that. We
Or
think.
the HDL?
More of the good one, less of the bad one.
Wait, so the LDL and HDL, they're not the cholesterol itself, that's the protein that carries?
Carries lipids through your body, yes.
So when, for example, like is it Cheerios? They have like a thing where like they're talking about like, oh, they can lower. I don't know if it
Lowers cholesterol, yeah.
So is it it's like it provides you with the HDLs, I guess?
I think so. There's supposed to be something magical in oats that does something good, but I don't really know how straightforwardly aligned it is. I think it has to do with fiber,
Fiber probably.
and I think fiber is just magical, but I have no idea how fiber like relates to this. If y'all are all free to. Yes. I got nothing. So you get these with saturated and trans fats, you get these with unsaturated fats. You on your plant-based diet are supposed to have a high amount of HDL, a low amount of LDL. But like in the past 15 years, we don't think saturated fats are evil anymore. And so like I don't know how we feel about this kind of outdated good and bad numbers. Like
I think it's just like a moderation. Like that's just like a general rule of thumb when it comes to anything, I guess.
support that.
Good moderation.
The last class of lipids that we are responsible for are steroids. Steroids all have this pattern of 4 fused rings, 3 hexagons and a pentagon. That backbone is in your data booklet. There is no part of you that needs to know anything about the backbone. You just need to be able to look at this and be like, ooh, that looks like a steroid. And I'll be like, ooh, you're right, it does. This is cholesterol. Cholesterol is necessary for human health. Cholesterol goes into that lipid bilayer, and you see it has like just the tiniest little polar piece and a really big non-polar piece. It actually fits into that lipid bilayer, and it gives structure to that fluid mosaic model, right? So we believe that there's nothing really holding that phospholipid bilayer in place, that they can flow against each other and change their shape, but the cholesterol is a big molecule that provides some amount of structure to the membrane or cell. Cholesterol is the starting material of the sex hormones, like testosterone on the right. So your body makes that. At some point, we were doing bad things to children and we weren't feeding them any fats. And so they were lacking the ability to do this, and that wasn't great. thought she's like all things in moderation. Regulate.
I just don't know, like, what does, like, the cholesterol do with that supply at different temperature?
Don't know.
Obviously, this person.
I've never heard this. You're teaching me. I like it. Most of the questions about steroids, again, are going to feature like your immense knowledge of organic chemistry. So a typical question about steroids is not going to be what does testosterone do, but instead is going to be like, can you name 3 functional groups in this? Okay, ketones. Sorry, I wasn't expecting it, but yes. I don't know if I call this a carbonyl. I don't know. I put a big. So I said functional group and you gave me class. And so I'm trying to be careful about that distinction because I have to play teacher sometimes, but I'm really quite terrible at it. So because I said functional group, I called it a hydroxyl group, not an alcohol, because I believe that the functional group is hydroxyl and the class is alcohol. Yeah, like I'm just trying to be good. But I would say what you said if I were the person in front of the room. I want this to take a lot of the pain out of steroids because again, this question is just a chapter 10 question couched in like this big complicated molecule. God, I'm glad there are people in this room that know what's going on in this picture. A hormone is a chemical messenger. We talked about the hormone insulin. It's a protein. This is a lipid. So hormones are not class specific. They go across all classes. Apparently this one's coming from the pituitary gland. Oh, no it's not. I don't know. You can read this. I know nothing about this. Nothing. A hormone is a chemical messenger sent from cells in one tissue, the endocrine gland, that act on the metabolism, formation or destruction of molecules of the cells of another tissue, the target cells. The control center is the hypothalamus, whose nerve endings release precursor hormones to the pituitary gland, which releases a range of precursor hormones.
This is like 3 different classes combined.
What on earth does all that mean?
It is.
Your brain squirts stuff,
Yeah, pretty much.
and it's gonna go places.
All the time.
Okay, so way to go, brain. Way to squirt stuff out. Doing a great job. Do you know all these parts?
Only the whole thing, not those tiny things.
No, we don't know. We don't know that.
I know it's a pituitary
I
gland.
just know like the brain.
I know the other stuff.
I know the brain. I know
You're insane.
Like legitimately, this is no place in an IB chemistry book. This is from the Pearson book, if you wonder where this is from. Like, there's no part there that.
I've never gone back into the pituitary gland before in my life.
I mean, it's super cool picture. Look at this.
Well, I hope you should share with the class.
The adenohypophysis.
I know pituitary small. You know that. I know the I know the whole thing in that sense.
Wait.
So cool. I can't wait to see what you guys become when you grow up and you know all this stuff. Okay. Yes, you have different organs in your body that make hormones. They do lots of different things that I don't care about. No. Like, I'm gonna go back to the question we get is, hey, estradiol, that sounds like it's for girls mostly. Look, it has 2 alls. That's why it's called a diol.
It's a pink hormone. Cholesterol and estrogen.
Cholesterol and estradiol. Well, you see, estradiol has a phenyl ring, while this has an alkene. And so I could do an addition reaction with bromine, and there would be no reaction here, whereas bromine would add. Like, legitimately, a chapter 10 question is where we're going. I do not.
It would ask you how to, like, what reaction you can do with cholesterol and estradiol.
No, the structure's given. The structure's free. Like, you just have to point at it and be like, yo, it's a ketone, everyone.
Okay, that's it.
Yes. Like, it's so simple. I don't know what Pearson went off on. They went off on this gross tangent. Like, I don't show penises in class very often. There we were, like, scroll, scroll, scroll.
We're learning introduction and experience. I have a question. So when people talk about obviously like the colloquial understanding of steroids being like the stuff that like people inject into their muscles, is it like testosterone?
So we usually don't use testosterone. If you're trying to like get huge at the gym, we usually use some derivatives of testosterone. I'm not completely sure why we don't use it, but it's in your notes because we talked about it yesterday, but it's not in mine because that would be like too easy. I don't know if it just has an easier time of persisting in your body, or if it has fewer side effects. So you know that if you start taking large amounts of testosterone, that your body stops making it. And so that can have some negative consequences on the male body. It also can, I mean, some positive and negative ones. But it also gives you like roid rage and, yes, it makes you angry.
When
Like
people go on steroids,
roid rage,
like when people
steroid
say-
rage, like
Oh,
they get
roid-
angry.
you're saying roid rage,
Roid
rage. Oh,
rage.
yeah, okay.
Yes. So like the 1 mark question on this is, why should Karthika not take steroids?
Well, they're bad, and you're fine the way you are. Love your
You're
body.
beautiful the way you are. So like we originally developed hormone therapy for cancer patients, and it has a role in people who are deficient. So hormone replacement therapy in aging women or in people who are having different kinds of cancer treatment was a positive change, but when it started being abused by folks, the negative consequences of both the body and mental effects. Okay, let's go, TOK. Madame. Donuts? I would assume it's about having too much, not just, like, all of us are making testosterone right now, it's the nature of being a human. But I don't feel particularly angry.
Yeah, but I was like, if someone had a deficiency in those hormones, say, okay, they started taking the actual correct amount, would it be like your body is thinking this is too much, therefore you're going to go into average? Or is it just the right amount for the human body?
I would assume that if you change the amount that you're making, you would undergo some of the more negative consequences. But once you had hit like constants, I would assume that you would be a normal person. Brecken is also gonna apply.
Even people that have testosterone replacement therapy don't experience roid rage. It's usually the anabolic steroids because it's like 10 to 100 times what
So what would a question like this look like on steroids? Something I clearly don't know a whole lot about. A question like this would look like identifying some functional groups. It could look like there's a 1 mark question proving you know some biology, but let's hope it's an easy one. And then it could be linked back to the chromatography, where we take urine samples from Margaret and from some competitor on the other team, and we try to see if we have evidence in that chromatography of the presence of steroids.
So when people take PEDs, are those steroids?
They can be, yes. So human growth hormone and testosterone are the 2 big, and EPO. If you've never seen the movie Icarus, I think it's a fantastic movie, and if you know, I've never really talked to anyone who's seen it. It's, so, yes. So it's about a age group bicycle rider, and he decides that he wants to win this like non-competitive competitive competition, so it's like you pay to ride a long way, and he wants to do better, and he's been like stuck in the middle of the pack, and he wants to go to the front, and so he goes onto a course of human growth hormone and testosterone to try to improve his cycling, but he ends up being like coached by the guy who was in charge of the Sochi Olympics in Russia, like the guy who hid the doping from the World Anti-Doping Agency, WADA. And so you get this like Russian guy from Sochi in his house, like telling him how to dope and talking. It's like, it's fantastic. It's crazy what people can do. And like, I don't know how many of you have younger siblings who are considering sports, but like a lot of the people that Joseph has played with have talked about taking HGH. Yes, because they feel like they're not developing at the same rate as their peers, and at what point do you look at someone and say,
Oh, Messi took HGH because he was super small when he was a kid, and that's why he didn't get into any clubs. So he had to get put on I mean,
like, it's interesting how pervasive it is, and like, I don't know what it's like in high school.
because I think there's obviously, I think it just ties into societal expectations of, men being stronger and bigger and taller and stuff.
That's right, but like, when you look at your brother, he's a bigger kid in ninth grade, I would say, but like, what happens when you look at the other side and you find one of the smaller kids? Are they developing normally, or do they need some sort of medical intervention, and how does their desire to play sports play into that? Like, y'all have so many decisions to make in your future, about yourselves, about any offspring you choose to be around. It's a crazy world.
I feel like in general, like the younger generation, like they don't look like I did at 13. Like they look so much older.
Dude, we put so much hormone into the water. We're
Yeah.
pumping it full.
Everything we eat is.
Like I literally,
Everything we eat has hormones. All that birth control you just pee out, like, let's go, hormones.
Apparently a lot of people take birth control.
Yeah,
And they're encouraging people to stop.
right, okay. It's real. Okay, you've done lipids, like, I'm sorry that the end of it is not super. You had 2 homework assignments that are due Friday, but a quiz next time, so I'm here to help you.
So, wait, I have a question.
Yes.
So if, for example, would you say, I know obviously like, agriculture right now is like big, that. So if someone were to grow like their own,
I don't think the seeds have an appreciable amount of hormone in them, but we do talk about how we've like, what do we do, artificially selected seeds at this point. And so I don't know if those are the healthiest vegetables anymore, because like what makes a tomato good for the supermarket or good for your backyard might not be what makes it good for your stomach.
Cause they do carrots and stuff, like,
Right.
tomato that like has a little lump on the side, like orange, like really bright, red,
Right.
juicy tomatoes.
That's right, but like tomatoes, like every old person I've ever met, oh, tomatoes in my day were so much better. Like, yep, been here, we are at the store, eating the same tomatoes.
Yeah.
I think Brussels sprouts actually thought it like tasted better. Like, they're actually
Is that why? Because I hated them as a child and I quite love them now.
I never got No, nowadays they're sweeter, but in the back then
Bitter? Okay.
that's how people like them.
I like them.
I still don't like them as a kid.
I think because I think they also sometimes this is another thing. Like what I always wonder like what makes like people like because there's people who like cannot like last year. I remember my last year my there was this kid who said like he had these like vegetable like a few years. And I was in shock. And then I kid was like, oh, he's drinking some brain.
And cardboard, just raw fiber.
Yeah, how does that happen?
What do you mean? Have you been to the downstairs?
Well, there's a lot.
No, dude, I can have brown meal like at least 3 days a week. Brown meal has no vegetables.
I know, because I'm just thinking of like, you can't even eat anything without like having vegetables. I would just be eating rice and stew every single day.
Stew has tomatoes in it,
Raw.
doesn't it?
But like,
I don't know much about stew. My
but it
understanding
has
is
like onions, tomato onions. I mean, it's not like leafy greens, it's just tomatoes, onions, and stuff. But I think, well, like what Lucy was saying last year about like when we were talking about the digestive system and everything, like nutrition and like the Western world is like very subpar. And that's why I
Asia has lots of fermented foods, things like kimchi, things that are fermented. Also in Africa, there's a lot of vegetables and everything. Like there's literally a fruit called F4 veggie, which translates to vegetable soup. And it's literally just like it's soup, but it's like 95% vegetable. Like sometimes my mom makes it and like there barely like any actual soup. It's just like vegetable ingredients. So like I always like vegetables growing up because it's part of my culture. So when I see like I guess like collectors like Americans or like Western people like years without vegetables, I couldn't even wrap my head around. There was also a kid who said that he goes for like a gallon of milk in like a week or something. Like a very short amount of time he goes for a gallon of milk. And we're like,
You're bound to account for a vegetable, right? Like,
and then she's
how
like
is that?
it's pretty easy.
I was gonna say, like, if you don't count potatoes as vegetables, if you wanna count them as starch,
I
I
guess
think
maybe
you're gonna find a lot of people. Like, in public school, when they have to have meals that are like documented to be healthy because, you know, we passed a law to or something like that. Like, I think it was Tipper. Like ketchup counts as a vegetable. It's made out of tomatoes, you know, and an equal part of sugar, but it's vegetable. The ketchup vegetable. So I've got fries, I've got ketchup, that's 2 vegetables on my plate. Like
I didn't know it's technically like processed vegetables, but then everything's processed like this. And then
it's frightful.
when she was talking about milk in particular, she was talking about lactose intolerance. She said like humans are not equipped to drink milk past like the age of 4, like a few years. We're not wired to drink milk.
Right.
We're not supposed to drink milk. The only milk we're supposed to drink is breast milk. And she mentioned that when people drink milk to the extent that people do in America, like growing up, I always saw like the drink a glass of milk, and that like I hate drinking like raw milk. I would only drink milk if it's like cereal or like a baked food, I guess. And even then, I drink it like once a week. I don't drink it that often. And she said that over time, like the way milk affects your brain is actually quite like crazy. Like she says that it almost has the effect of people drinking to like a large extent. It almost has the effect of like a drug almost.
I know they've said that cheese can behave like they've had like pictures of people's brains on cheese. Like, yeah, that's kind of how I feel about it.
But-
I like cheese.
But like cheese, I asked the question, I was like, is that where the whole, I guess, stereotype of drinking milk to get sleep comes from? She said, yeah, because it like almost sedates your brain so much. Like people who drink over and over again, it has a really, it changes their neurochemistry so that it has a calming effect when they drink it, which is strange.
Is that why I like nighttime coffee so much? It has milk in it.
Yeah, I guess.
I love me some nighttime coffee. Yeah, let's go. It's on camera. We're gonna do 1E on the lipids homework. Is that not fun?
We'll find out.
I don't know, it's a math problem. Brett said it was hard.
The wording is weird. Like,
Here's my forward employment.
I guess the word's more.
You did bad in a Karthika world, not bad in like a.
Objective world.
You got a sticker and you think you did bad?
No, it's like you did good sticker. All stickers are good when I work.
So want people to say that about me someday. So nice.
That's my boss was sexual harassment.
I'm trying to make it work on here. It's sucking. Have you guys tried Bard yet? Bard? Google has its Chat GPT. Came out today. It's called Bard. I wonder if it's gonna write my English IO.
And wow, we were like trying to learn, we were cramming for bio, Making Friends, Forrest Gump style.
Forrest
And it actually wrote something and we were all like, wow.
good?
The prompt wasn't good either way, so. His nickname is actually all very. It's already able to, I saw the video where someone was able to make it sound like it. Makes it sound exactly like it's not the same.
Is there a difference between
In the speech,
I believe the other one is linoleic. So I believe there's an N difference and they are different. Yeah, I feel like that's why they threw the alpha in there.
Wait, so it's like the question is asking what we're trying to do, which is here, it says alpha linoleic.
Okay, then no, no difference.
There's a difference. So this one has 3 double bonds per fatty acid. Then out of 6, I choose better.
So this is a triglyceride, so I would have guessed it was 9, but now
Wait, what question is this?
1A lipid.
1E. I don't know, like I just took the formula that they gave me and I didn't worry about it.
No, so because my question is, so isn't it how many double bonds and how many ions?
Yeah.
So I go to.
So you think there are 9 and I think there are 6
No,
because,
you're definitely right with one.
I don't know, because they gave me the formula. I didn't read 1A, B, C, or D, I just did 1E, because that's what you asked for. Linolenic.
Probably not the same. I just guessed that it was going the same. 'Cause it's-
Yes, I understand, like I just guessed it to be a standalone problem. Okay, like that was a really boring conversation, like, sorry it was too easy for you. Linolenic, it's a fatty acid, omega-3. They're both omega-3s.
Protein.
Draw the correct shape, explain the solid of the triglyceride. So you think that's just the wrong formula? Linolenic. No, this is good. No, this is bad. Yeah, they just messed up.
I didn't even look at the formula or something. I just do.
Okay, so if you wanted to be yours, like we're just gonna make this an 86 and go on with our lives.
Okay, so that's gonna be 9.
So, oh, that's gonna be 18. That's right, sorry. Oh, I mathed bad. Why can't I math? That's 8 and 16 is 24, right? This was 12. But you don't want this number to be 12, you want it to be 18. I don't know, what did I do wrong? So I have to subtract 6, so this has to be 80. 36. 36. Okay, 80. Okay. Is that better?
Yes.
Okay.
So I read that part. I don't know how to.
So I claim that once we have this balanced chemical equation that we so carefully fixed to meet your expectations, We know it can take 9 I2s because we know the IHD was 18 or 9 double bonds. So the molar mass of I2 is like 254, and we have like 25.4 grams, so we have 0.1 of a mole. So if we have 0.1 of a mole of this, we have 0.1 of a mole divided by 9 of this, because there's a 9-to-1 ratio here. And so this is going to be 0.011111 moles. But we know the mass, and so if we take this and multiply by that, we should get the answer of how many grams of this we have. And so I don't see anyone coming to my rescue, so it goes in 9 times, 7 times. Oh, you like it when I do made up math, though. I know you do. I got 9.7. You know, it's music. What I do is done. I can take it. Does it say poopy, or is it just wrong? Okay, so we changed the problem, right? So Karthika read A through D, and she believes that it should have had 9 I2s or 9 double bonds because she'd been working with lino whatever acid the whole time. I don't know the difference. Linolenic, she'd been working with linolenic, and they like changed it, those crazy people, to linoleic. Oh my God. And so she wanted it to be consistent, so we just changed the problem to meet her high expectations. I don't care which problem you do. But we figured out how many double bonds there had to be mathematically as well as conceptually in the problem. We set up this ratio. I calculated the molar mass of this. We knew the mass. We calculated the moles. We knew there was a 9-to-1 ratio. Sir. How did we find what? We took so I believe that you have 0.1 moles of iodine. I believe that there are 9 moles of iodine that react with every 1 mole of triglyceride, which I will effectively call that. And I believe that 1 mole of triglyceride has a mass of 873 point, I've already forgotten, 5. So that should give me grams of triglyceride. So I think 9 goes into that, a polite 9 and 7 times. Oh, she's getting, yeah, 9.7. I think. Multiplying it by 0.1 and dividing it by 9. So 9 goes in 9 times, it will be 63, so 7. So this is 97 times 0.1 is 9.7. And Karthika got out her calculator to make sure I wasn't doing something else. Because she doesn't trust my mental math. Right, doesn't trust my mental math. Nope, I have a calculator. I just didn't see it, so I. Any other questions on lipids? It's open.
Is the last answer 3, is it just partial hydrogenation in nickel?
Like you want to know how to make the trans from the cis? Yeah.
Oh, yeah, that's what it's asking.
Yeah, hydrogenate it.
So it's just
Nickel.
the answer is just partial hydrogenation?
Yeah.
Those were all my questions.
Oh, let's go. You're saying I should do this assignment? I feel like Margaret beat me. It's you again, isn't it? It's like one person has submitted. I just assumed. Lipids, 3.
No, I have not.
No, so someone else don't. Maybe they're really clever. Maybe I should pull up their answers. I would have pulled up your answers, but you were sitting there like I didn't know. Number 4 on protein. We're gonna do number 4 on proteins, everyone.
Or it's 5B.
5B?
On this side, though.
4, 5, whatever works.
Oh, right, I have that down.
5B?
Oh, yeah.
Do I need to pull up the answers on the computer and try to make it look subtle?
I do know what it's asking.
Okay, I'm gonna read A this time, so y'all don't think I'm dumb. The isoelectric point of alanine is at 6. State the structural formula of alanine in a solution with okay. So you agree that here it's a cation, here it's a zwitterion, and here it's an anion? Okay. Outline how 3 different amino acids A, B, and C with isoelectric points of 5.1, 6.3, and 7.6 could be separated using page. Let's go.
Would they able to tell us the buffer in the
You have to choose it. That's how you're separating them. So if you chose a pH of like 10, then they would all go one way and you wouldn't separate anything. But if you chose a pH of right around 6.3, one's gonna move up, one's gonna move down, one's not
I
gonna
was
move.
just like, depending on the pH of the solution, it's gonna move.
So I think that you're gonna set it up so that the pH of the buffer is 6.3. So B will not move. A will think it's in a basic environment, and so it will move to the positive pole. And C will think it's in an acidic environment and move to the negative pole. You might wish the word move was in there a few more times, and you can certainly write things that are more English. Does that make sense? Yes, ma'am, because I knew the PIs of my amino acids, I chose the intermediate ones to be the pH of my buffer, because that one then would not move. Because it's the same, right? So it's a zwitterion, so it has no net charge, so it wouldn't be attracted to the positive or the negative side of my electrophoresis machine. Did you have any luck with that? Electrophoresis? I thought you were trying to get the electrophoresis contraption. Did you have any luck with that? Okay. I'm Roger, sorry. Because it thinks it's in a basic soup. It's gonna be deprotonated, and so it's gonna be negatively charged, and so it would move to the positive pole. B won't move at all, and C thinks it's an acid, so it will be protonated, so it'll move to the negative side. Yes?
That's like the thing you mentioned where like if it gets more acidic and contains it,
Yeah.
you can completely like change the end group.
Yeah.
Our group. Are you using 3' in the same sense as like form from?
Tertiary structure.
Okay.
I thought it was the pool or the
No.
charges. Like depending on the pH, the charges will change over there.
But now we have a whole enzyme. So all the Q's and NH's are bound up in peptide bonds, so they're not changing. It's just the R group. Yeah, it's coming out of my head. I apologize for that. That's going to be changing whether or not it's protonated, so we're not going to be able to make those same interactions. I know you guys think there's enough room to answer the questions in here, so I was trying to like channel that and make it fit.
Wait, so A is the 5.1. That will move to the positive side because
So A is the 5.1. So from its point of view, it's in a basic solution. Right? Because the solution has a higher pH than it. And so since it's in a base, it will be deprotonated. And and so it will have a negative charge. Meanwhile, C is isoelectronic point is 7.6. When it looks at this, it's like, yo, I'm an acid, so it'll be protonated, and so it'll be a positive charge. So because of that charge, it will be attracted to the opposite side of the electrophoresis instrument. Yes? That seems likely. Explain why increasing the temperature increases the rate of an enzyme catalyzed reaction, but only up to a certain point. So more molecules will be able to overcome the activation barrier, but once the molecule has enough kinetic energy, the movement of the R groups will be too big, and they will overcome the potential energy interactions holding them together. So you will break the tertiary structure. Let's see if we can write that in a sentence that's not terrible. I'm sure that many of you phrased this better than I did. I'm not very good at writing on the board. But it says, as the temperature increases, more substrate molecules can overcome the activation energy, so the reaction speeds up. But when the temperature is too high, the kinetic energy of the side groups, the R groups, the side chains, will be large enough to overcome the potential energy, by which I mean any bonds, ionic bonds, the cysteine linkage, the hydrogen bonds, intermolecular forces or tertiary structure, like whatever's holding them in place, and the enzyme will begin to denature. I don't know that we have to talk about potential energy. It was just the shortest way I knew how to convey those things, and that's why I shoved them in parentheses.
I just said that the bonds and interactions are maintained along
That's what I'm trying to say, right?
Does it have a side group and R group?
This is the R group of the protein.
Why the R group?
Because those are the weakest interactions we have, right? We just have intermolecular forces for some of them.
Because is that referring to like tertiary structure?
Yes, we are breaking the tertiary structure. We are unfolding the protein, we are not lysing the protein.
Are you able to simply say that in process?
I don't know, it's not an IB question, it's a homework question, make you think about this. So like, I don't have a mark scheme.
Are you referring to tertiary in the sense of like, organic chemistry, like the shape or tertiary, like the,
That's second, well, I don't,
3D of the.
yes, I'm taking the 3D of the protein. I think you have to explain two things in this question. The first thing I have to explain is why the rate goes up, and then you have to explain why the rate falls down. The rate goes up because we have more molecules that can do it. The rate goes down because you break the tertiary structure. I don't know how many words you want to put in break the tertiary structure. If it's a 2-mark question, I'm probably going to be pretty freaking terse. Right? My tendency is to write a book and not think very hard. I'm glad I don't have to grade my own paper. I know you walked out of biology test saying I wrote everything I knew. Like I wrote it all, and I hope I get the marks. Like that is very much my structure here. Like I don't care what's in the mark scheme. Like that's That's what I mean.
Two marks for construction of essay.
Yes, you guys have to write well.
But yeah, so is that for every part or for, like, as it is it only paper three or paper?
I thought it was the second part of paper 2.
Yeah, the second, no, correct, the second part was computer, right, and so there's, yeah, this marks for the construction of essay.
Yeah.
It's like if you're like, stuff doesn't make sense, or if it's hard to grade, it takes time to grade,
Yes.
they can penalize you.
That's right. Because we don't want diarrhea of the pen. It's hard to grade.
Like if they have to like search for like.
You don't want diarrhea of the pen, don't give us questions.
And like in chemistry, we're pretty nice, right? Like everything can be bullet pointed. You never have to write a sentence, but sometimes like it'd be nice if you did, because I don't really know if you know what you're talking about.
Right sentences that they just have to make sense, like as in like it can't be difficult to grade, like they can't be like searching for like.
So don't be on.
What?
Don't write like on.
Yeah.
I think if that
Yeah.
is the point they regrading the.
Basically,
I've never graded a biology
I
paper.
don't know, because I didn't know that this was a thing, it's like.
But yes, it's definitely, there is a construction of the essay.
You ever, graded chemistry?
Yeah.
I haven't seen it hard, was it hard to
And some of them are hard to grade, some of them are really easy to grade. Sometimes you debate it a lot, but like, it's pretty easy to be within tolerance of the,
It doesn't exist.
so sort of, I think you have to grade 5 papers, 10 papers, and they have to be within tolerance. And once you've done that, you're off the prelim and into the let's go. And then one of every 10 or so papers is a seed. And so if you don't agree with the definitive marking, you can go into jail and your boss has to let you out. Or, like, it depends on how egregiously wrong it was.
There's no chance that you get a paper
I don't know. So one time, like, I was convinced I knew the handwriting. And I was like, this really looks like, I don't remember who it was, but like, it really looks like my kid. I don't know how sophisticated their algorithm is, because at some point, like, it's just downloading another 10 for you to be able to mark. So you can only own a set of them, not all of you. The allocation is 150 papers, but they're afraid you're not gonna do all your work, right? So they'll give them to you 10 at a time, so the 140 are there for Raimi to grade if she's grading faster, because they're looking for,
Do I get paid if I grade faster?
well, you get paid per paper,
Oh, okay.
but there's a limit as to how many you can, like, there's an allocation of how many you're expected to do. And then sometimes, wow, you're doing great, would you like some more? I've never gotten that, in case you want.
When you draw a triglyceride, it's like the opposite way of how this is.
I always seem to draw them backwards and it doesn't matter.
Really?
Like, as long as you have an ester,
Oh, so I can draw it like this way, like the glycerol here.
yes, I just don't know how to do that. I'm not joking, okay?
Oh, okay, so you flip it over like this. right?
I just, yes,
So my question is, if you write it in like this
Yeah.
way that they've done it, but like you would have to do it backwards, right? And what about the stuff in the parentheses, if you write that backwards as well?
I would struggle. But yes, I would. I'd write it backwards.
So we can show you.
Yeah. I'm scared I'm not gonna be smart enough for that.
No, isn't every question that we produce I know. So when I drew it, like,
Yeah, that ain't it, right? The double one has to be a part two.
so it's gonna be like that.
Yes.
So I like flip it over.
Yes.
And then this one is also CH3 SPAN. So I just have to remember that I need to like draw everybody.
Yes. But you can also draw it the other way, like I'm just really good at making that ester link that way.
Now I think I
I'm certainly not trying to make it more complicated, I just have patterns to draw, right? Like you guys all put the arcs down in biology,
Yeah, we do.
and like I always put them up in the data book where they're down, but like I always put them in, so like I'm not gonna change. Like, it's a 2D picture of a 3D thing, and everybody wrong.
So is this just asking to draw the three of them?
Yes, those three.
And this one is, the next one is just like the other way.
Yes, how many ways can you do it? Does it say math?
This,
Yes,
that's the
three
right
factorial, yes. residues is an R group.
So we don't have to draw these separately.
You just have to count them, like state how many other, oh, and so this is a emergency answers 5. Because there are 6 total and you choose 1. And the question, if you read it again, says how many other. Isn't that just mean? Like that is a real ID moment. Isn't it? Because it's like, I know you understand this, but I wanna see if you're actually reading the question.
That's kind of,
Mean. Like there's just no reason to put that trick question in.
they're preying on our downfall.
They're preying on the fact that you're nervous and. So you've got to take this Q and this, this Q and this NH2 and make that, and make that peptide bond. And then take this Q and this NH2 and add the threonine R group.
So it'd be like.
So make a peptide bond between these.
Like you're drawing this picture with the backbone, so you're gonna have 3 residues, 3 R groups.
Oh, we need to do the backbone?
And you have to, you're making it by taking the Q and the NH2 of the next guy.
What did you
Would
say
you
about
like me
this
to draw
other page?
this?
Yeah, because I thought it was like.
She has threonine in her list, so this one as well.
'Cause
Yes.
I thought you like you do this and then you continue and then.
Yes, that's
Is
exactly
that-
what I'm saying.
But that's it's not different than the squid with the.
So I'm saying you're actually drawing the backbone, like you're drawing those nitrogens and carbons.
Oh.
Instead of
Whereas
just
they've
using the
just drew
line.
like a line. Like
Okay.
this is asking you to actually draw the atoms.
Okay.
Like, you're doing perfect.
Just take notes here.
It's very close to the diarrhea of the pen we were talking about. There's a theme to this conversation. There should be for response, but there is no multiple choice in this section. I'm not sure if Faculty has any, but paper 3 is all 3 response. There is not a single multiple choice inside.
How was yours? Mine was pretty like emotional.
Oh my god.
I mean, I was like, okay.
Mine was quite informative.
It's a journal entry. It's supposed to be like, I framed it in a way like, I was like, okay, I started writing, I did some writing this right now because my family finally pushed me to get there at the end. This is what my therapist told me. That's how I
Oh, look
started
at
my-
you.
I mean, because she said like, there has to be an emotional aspect, so I kind of took creative liberty.
I like it, but it also like directly got you there.
I think mine was going more like fun. Because I read that like people of color who are diagnosed with multiple sclerosis tend to have like there's a trend that they have a little more aggressive forms and they're also harder to diagnose. And so I was just like, wow, that's
What's up?
yeah.
Let's go, Mama. What you got? I don't know why, yes. I don't. I feel like I did a really awful job of explaining it, because, yes, that is my intention.
I just didn't know like a residue.
R group is residue.
So just need to make sure to show that there is.
Okay, you guys are HL dose.